Okay, let's welcome Abhishek.
So hello everyone, my name is Denis Kondratenko. I'm working in SUSE for storage product that is actually based on Ceph. And today we will talk about the Ceph and the ELK. We will talk about it from the different perspective, not like we are going to run ELK on Ceph, but how ELK could help us with Ceph a little bit. And probably everyone know what is the Elasticsearch is, what is Logstash, Kibana. That is stack of different products from the Elastic. Elasticsearch is basically the database. Logstash is server pipeline that actually allows you to get data, transform it somehow, and to put it probably in Elasticsearch. That's what they claim. And also Kibana is the GUI for all this, so you can query from it to Elasticsearch, monitor something, and etc. XPack, it's actually another product that provides you machine learning and alerting from same Elasticsearch database. What I am be talking about is logging. So actually everyone knows that Ceph is cluster solution, and we have a lot of logs that we need to gather somehow, put it somehow in database and alert the people that there are some problems, so just analyze it. So how you can collect it, it's actually well-known, old technology is rsyslog, syslog-ng. You can just gather it on the node and push it to the Elasticsearch. As well as they have also FileBit. It's special applications that runs on the node. You can run it that will not just gather the logs, but also pre-process them. As well as Greylog, Ceph actually has the built-in Greylog support, so Ceph itself could forward the logs where you want. For that, you just need to configure it somehow. Why we need the logs? We need logs to store it for later use, for analyze, like analyzing it to understand if there are some problems happens, crash happens, you just could alert immediately someone. And you also can analyze those logs with machine learning, and that's built in XPack. And as well as Elasticsearch has a good client for R. So that's how you can explore those logs. And yeah, for sure, when the cluster is dead or some node is dead, then you get, as the developer, sleep of the logs, and you need to analyze them. So you can forward those logs, as I said, with rsyslog. rsyslog has a built-in functionality. You can just configure it so it will run those logs in Greylog to the server. And Logstash itself, it's why actually I'm talking about Elasticsearch and Logstash, because it's really simple framework with a lot of built functionality. So it's already could parse those logs like syslogs, like Greylogs. It's already built in, so you do not need to do something for that. As well as they have FileBit that could collect information for you and push it to some server. Ceph Greylog support. So it's built in, it's not really documented, but you can find these parameters in the Ceph itself, and it works. At least for me it was working fine. But so you just need to configure those parameters, restart the Ceph service one by one, for sure you want that. And for example, we are using the DeepC, that's salt-based configuration management, so you can run one command, and that's everything you need to do. And then Ceph will forward those logs to Greylog server. And in my case, this Logstash, for example, and Logstash could collect this log and push it forward to the Elasticsearch. So as I said, the Logstash already provides some primitives for that, but you could not just parse, not just push it to Logstash, but also pre-processes. For example, you can find some fields, and that's easy to do with grok patterns. It's just the regular expressions that you can use that will pre-process your logs and, I don't know, just push a little bit more information into the database, or just used for alerting. There are a couple of examples. These slides are available in the link under our talks, so you can go ahead and look on examples. How this is Logstash pipeline. It's like filter part of it that actually parse Ceph logs. It's like two 2 lines of the regular expressions that actually parse all the Ceph logs. So we have 2 different formats in Ceph somehow, and these 2 lines as example how to parse it. So it's just some timestamps, some fields from the logs like thread, and etc., etc., etc. So to actually, as a developer, you probably need to have some development Elasticsearch cluster. It's really easy to deploy in the Docker, and I used Docker Compose. It's just like couple of it's one YAML file where you define your cluster, you push Docker Compose up, and it brings up like 2-3 nodes cluster with Elasticsearch, Logstash, Kibana. So this is example. It's really pretty straightforward and easy to use for development. So I can advise you to use Docker Compose for that, for development purpose. And why we want to do that, it's actually gather it together in some interface and actually expose this interface to the user so they can find out something. Myself, I see the use of this tool for sure for some troubleshooting. Like you have the logs, you are level 2, level 3 engineer, maybe developer, and you have dashboard that actually queries Elasticsearch for some known problems, for example, or some hints that you can see the picture of it just on the screen. That just will speed up your development or your troubleshoot analyzing or whatever. It's maybe will say you in future what kind of problem you have. So Kibana has built-in functionality for dashboards, for querying the Elasticsearch database, so you can actually easy to do that. So there is one example. We have support config. That's special tool that our level 2, level 3 engineers use to gather the logs from the cluster. Like they run it node by node and then send it to us as developers, saying like here is some problem. And actually, as a database already preparsed, you can build like cluster picture. Here in the example we have like how many nodes we see in the logs, what is the kernel version, what is the Ceph version, and what kind of problem. Here is like just a simple query for health, not okay, like health warn or health error. So that's actually give you some idea of the current issues on the cluster, as well as you can use simple searches then for the database to see actually what happens in the cluster. So my idea may be that we can have some patterns and defined some searches and queries defined that could say you as a developer or support engineer what happens, what's wrong, what maybe the basic issues. Like here in this example, it's like Rados Gateway cannot find the key, I believe. Yeah, that's failed to start the Rados Gateway service. And if we will have such list of patterns we can parse, we actually can quickly and more quickly actually find out the issues or the state of the cluster. For sure, you can use the Elasticsearch real time and discover some of the problems as well. So that was my part about Elasticsearch, parsing Logstash and of parsing the logs. And right now I give the microphone to Abhishek, who will say a little bit about different approach, how we can use Elasticsearch more.
Can you hear me at the back? Okay, can you hear me at the back now?
No, its microphone is not working, it's just for...
Okay. Okay, so I'm here to talk about the Rados Gateway, the object storage component of Ceph, and how it actually ties into Elasticsearch. So a bit about Rados Gateway. So this is the object storage client to the Ceph cluster. By client, I mean it's a librados client to the Ceph cluster. So it basically translates your HTTP requests to librados requests. And librados does all the intelligent placing of data and based on your storage policies and everything like that. So yeah, it's basically a RESTful API access. It provides you a RESTful API access to the Ceph cluster. And Kai already explained about Ceph Cluster in his open attic, so I'm not covering more about what is the general architecture of Ceph or anything. We provide basically both Swift and S3 API access to the Ceph cluster. This is primarily because like most of the client tooling for object storage is already built around these two APIs, which are like very well known. So it makes sense that we actually expose these APIs rather than some of our own APIs to access object storage. So since there's already a heavy ecosystem of this client tooling, we just reuse the S3 and the Swift API, and most of the clients are happy with that. And we have these concepts of user accounts, buckets, ACLs, and everything, which are similar to the Swift and the S3 concepts of these. We support a lot of S3-like features, and we have cross access with S3 and Swift. But the thing is, like, since both the semantics of both the APIs are completely different with some of these protocols, it's like you cannot actually upload an object with multipart in Swift and not access it in S3. So you have a lot of S3-like features like multipart uploads, object versioning. You can download the object as a torrent. You have some lifecycle policies which allow you to delete or expire objects. Then you have support for encryption. There is some compression support from Luminous release of Ceph. You can actually host a website with static websites, and now we actually support metadata search with Elasticsearch. From the Jewel release of Ceph, we have this concept of multi-site, which is basically geographically redundant Ceph cluster. So you can actually replicate your Ceph cluster geographically to another remote location, and basically transfer your S3 data. So that is the concept which this is built on. So Elasticsearch, as Dennis already explained, it's just a distributed, horizontally scalable document search engine built on Apache Lucene. So it basically speaks a RESTful API, and literally every configuration you do on Elasticsearch is done via REST. So it's pretty easy configuration. And the motivation behind why we need to build something like metadata search of Rados Gateway objects with Elasticsearch is basically that you already have a lot of metadata associated with your objects. So for example, if you're doing video analysis, then you may actually have a tag saying like this video is uploaded by this author or this user or something like that. And you might want to actually query and find out how many videos are uploaded by, for example, Dreamscape with what average sizes or something like that. And since it's an object storage, you do not have any traditional file system or analysis tools at your disposal. We have some support for this in terms of Rados Gateway admin API. So you can actually get specific metadata when you query for it, but the problem is, since it's very specific, like if you ask for this specific bucket or this specific object, I need metadata, then we'll give it to you, but that doesn't lend itself very well for analysis. And you actually have no notifications when you have like new objects or new buckets or new accounts being created, so you have to constantly poll and write a very large-scale system to actually analyze this. So this is where Elasticsearch already comes in, because it has already built-in primitives for slicing and analyzing data. And permissions for users to access an admin API is also tricky with the existing API, because it's only meant for administrator and it gives you full access to all the metadata. So as a storage administrator, you want to actually analyze what are my top 10 consumers of the object storage, or what are my really hot buckets, or how is my object storage being used on Friday evenings, for example. And all this is something that's very trivial to be done with Elasticsearch. So the design, it's actually built on top of the multi-site architecture. So in multi-site architecture, what we actually implemented is that you have two Ceph clusters and two Rados Gateway Ceph clusters, and you are basically translating the object uploaded here onto another remote site. So you have already semantics for asynchronously basically copying data from this cluster to the other one. So since that is already there, and Rados Gateway is the consumer on the remote site, we actually thought that we can actually leverage this to consume it not only by a Rados gateway, but for a third-party plugin which can actually forward this metadata and data to an external tier. So what we have already built in is like Elasticsearch from Kraken release of Ceph, which is basically that we have the metadata already, notifications from the remote site, so you just forward it to the Elasticsearch. And the same concept can be actually used to build backup solutions on top of multi-site. So you can actually have a plugin to sync objects from your Ceph cluster onto Amazon Glacier, for example, or Amazon S3. And you can even, for example, write a custom, sync plugin that would actually sync your object data to a tape, because it might have a custom, semantic to actually, write an object to a tape. And you can build something like Amazon Glacier, because now this is actually possible because you actually know that there are notifications when objects are uploaded, and how to pull the object from a remote site. So this is the concept on which the Elasticsearch plugin was actually built. So essentially you already have the metadata from the remote site, and you just forward it to the Elasticsearch instance. And what you have is a remote Rados gateway that is just purely a forwarder proxy of sorts that actually pulls data from the original Ceph cluster and just forwards it to the Elasticsearch. There are some problems with this. You do not have a off-the-shelf authentication module that can work with Elasticsearch and Rados gateway users. And you really do not want to expose your Elasticsearch endpoint to the public, because if you actually have information about your object metadata, then that will tell you almost everything about your storage. So you don't want to expose this in public. So what we built from Luminous release of Ceph is, like, for normal users, RGW itself can actually authenticate the end user, and actually for an end user who is a user of object storage, he can also use the power of Elasticsearch to analyze his own user account and object metadata. So in the object metadata, we already have an attribute for the owner of the object, and that's how we actually authenticate and make sure that the user only sees his own data. And we also have support for custom metadata fields being indexed in terms of Elasticsearch fields, so you can actually not just do the basic text attribute, but you can do dates and other kind of attributes. So this is like a very trivial diagram of this architecture. So you have a primary Rados gateway and the primary Ceph cluster, that's your normal regular storage cluster. And then you actually configure a remote zone and the RGW that only reads metadata from this primary cluster. This can be in the same Ceph cluster or a different Ceph cluster. I'll recommend a different Ceph cluster if you want to be completely redundant and not depend on your primary data store. And then you just forward it to the, this Rados Gateway basically forwards the metadata to the Elasticsearch cluster. And this is actually not just applicable for a single primary Ceph cluster. You can actually have a ring of 3 or 4 Ceph clusters like Amazon US East and US West and the Europe Central region, and forward all these metadatas to a single Elasticsearch cluster. This is like the example JSON of the metadata we currently forward to like Elasticsearch. So you basically have the name of the bucket and the name of the object and your object versioning and the owner attribute. You also have some basically the metadata which tells you about the size of the object and the time it was uploaded, and even if you actually, from last release of Ceph, we also have support for object tagging, so you can actually attribute custom metadata per object. So you can say like this key and this value are associated with this object, which is very useful when you want to slice your data based on a key. For example, you need all the videos by this author or all the books written by an author or something like this. Since it's Elasticsearch, you can aggregate queries pretty easily. You can just give an average of the total objects uploaded, or you can even do it on a date basis and something like this. And the Elasticsearch will respond to you telling this is the total average. You had total 22 objects and the total size was like 177 bytes. You can actually have queries on specific metadata content, which can actually help in finding out data from specific users or something like that. Then this is the future work in place. So we right now have support from Elasticsearch up to 6 for Rados Gateway. So the future work is to support Elasticsearch 6. Then custom metadata fields for object tagging, which we do not have support for right now. Then the next work is for the plugin to actually analyze common system faults, the Logstash plugin, and integration onto Ceph dashboard and analysis with, for example, machine learning, which Elasticsearch provides or something like that. So the support config is a repo for what Dennis demonstrated with the Docker and everything. And these are the official Ceph repos and the IRC links and everything like that. And questions. How many minutes do we have? 5 minutes. Yes?
So do you have any experience with larger clusters on these metadata stuff? So how big are your clusters and how many data you have tested?
So the question was, do we have any data on very large Ceph clusters and Elasticsearch? Answer is not really. We do not have any customer data right now on Elasticsearch. But the answer is like we actually do not. We are not dependent on this primary Ceph cluster at all for the metadata. This is completely, asynchronously mirroring data. So it's not. It's not real time that your metadata is actually there in Elasticsearch. There might be a delay, but it's not affecting your primary cluster at all in terms of your IO path or metadata path or any sort of path. Any other questions? All right. Thank you.
Thank you.